Okay, welcome Ann Arbor Library patrons. Tonight I'm going to take you on a tour of the universe using a live telescope feed. You're going to see the pictures as they are taken, the moment they are taken. And I will want to encourage folks, since this is YouTube, there's a chat function and you can type your questions. I'll try to get to them. But the first thing is I want to show you a little bit of video that it explains me and how I got here. I apologize, it's from Astronomy at the Beach from back in September, but it does a great job of really telling what's going on here. So I'm Brian Ottum, and tonight we're going to see a tour of the universe, and they're going to see a telescope and lots of cool pictures. You'll see the pictures live as I take them. You're going to see the telescope at work with a live video feed showing the telescope working. And since it's a tour of the universe, we're going to start close by the Earth in our solar system. Then we're going to end up way, way in a galaxy far, far away, further than that. So I've been an amateur astronomer since I was 12. I'm a fanatic. I've owned lots of telescopes. I even had a dome. I got hooked on taking pictures, though, of things in addition to just looking through them through the telescope. So I got started by taking pictures of things that were close by, you know, meteors and the northern lights. That's fun. You just put a camera on a tripod. And sometimes I'd love to travel and see things like the total solar eclipse and taking pictures of that. But unfortunately, my dark backyard skies were becoming very, very rare, and all around the United States you can see that we have light pollution. It's getting worse and worse and worse, and most people can't see the Milky Way from their backyard. And the problem is just getting worse. And so in my own case, I had to take action. I moved my telescope and my camera from my backyard here in Michigan all the way across the country to a place called Dark Sky, New Mexico. And it's down in the desert southwest. It's close to the Arizona border, not far from Mexico. And there's absolutely no light pollution, so when you look up, you feel like you're falling into outer space. And so this is a tour of the telescope ranch via drone, and you can see that these observatories all have roofs that roll off on wheels, kind of like your garage. And the big white roof there, that's our observatory. I have a couple partners, and you'll see the telescopes inside as it opens up in a little bit. The buildings here contain between 1 and 9 telescopes. It's clear over 300 nights a year. It's 4,000 feet elevation, and so you're really not looking through much atmosphere, so it works really well. If you see that blue deck there with that big red telescope, that was Clyde Tombaugh's personal telescope. It was the guy who discovered Pluto. Now, earlier tonight, I opened up the roof when the sun went down. It looked just like this, and there's a lot of heat trapped inside, so it's important to open that roof at sunset to let the telescope and the camera cool down. And as you can see, the roof slides off to one side on wheels, kind of like your garage door. And so that shows pretty much what it looks like when you are looking at the telescope. And so now I'm going to have a more of a live view, and so I'm going to minimize my video. Okay, so there is a live shot of the telescope. It's as you can see in the background of the telescope, you can see that the sun has gone down recently, and there's still a little bit of light in the west. And so that's a live view of the telescope, and so you can see it is a 10-inch reflecting telescope in the black tube there, and there's a Canon camera on top of the telescope that's inside that shiny shoebox at the end. It's a homemade cooler because it keeps the camera cool, because in the desert things are hot. Cameras don't like hot. And the white thing is a one-armed telescope mount from Planewave, made here in Michigan. It's the Planewave L350, and it's a robotic computerized mount, and it's really the most important thing of this whole rig. So now we're going to take a smaller view of the telescope so you can see our agenda. You can see now the sky, and so that view of the sky there is, and I'll make it a little bit simpler here. What you're seeing is all of the constellations and basically all of the different things that we might be able to see. I'm going to close up some of these lines because there's just too many lines on the screen here, trying to make it a little bit simpler for you to see. So in our tour of the solar system, let's start with something close by. And the moon is not up tonight, so we're not going to be able to see that. I usually show that first, right, because that's close by. And the closest planet to us is probably still Venus or Mars, and we're going to look at Mars. But I want to look at Jupiter and Saturn, because if you don't know, they're going to be coming so close together. They'll be closer together than they have since the Middle Ages. And so that's something you're going to really want to see here. So what I do here with the telescope is I simply click on Jupiter, because it's down here. I will zoom in a little bit. There's Jupiter, and I hit the Go To button, and the telescope will go to it. Now, the internet is very slow in the desert tonight. So the camera, as you'll see, is on about an 8-second delay. I have to apologize for that, but we're going to be able to take pictures and see stuff here tonight. So the first thing we're going to do here is we're going to look at some Jupiter, and we're going to look at it with a live video feed. So I'm sticking it on video here, and we're going to be able to see Jupiter here in a second, and it's 4 moons. And what this is here, this is a star here that we are looking at, because with the telescope you need to focus it, and so it's very important to make sure that telescope is focused at all times. And so I worked with it earlier before you guys got online, and all right, we're gonna go back on that there. All right, yeah, all right, now we are seeing, this is very cool, because what we got here is a live video shot of Jupiter, and it's 4 moons. They call these the Galilean moons because Galileo saw them in his telescope. And so the things are a little bit slow out there. Bear with me. We're going to be able to get through this. There we go. I'm going to zoom in. And we zoom in. And up there, Jupiter has disappeared. So I think what's going to be a little bit easier is what we'll do here is we'll just take a static picture. So I'll take a flip over to the camera, and I'll make it a static shot instead of a video. And we will change it to, I think when I was testing last night, Jupiter is so bright that we just need 1/100th of a second. And as you can see, this software runs the camera, and I'm just selecting 1/100th of a second. You can see that I select 1/100th of a second, and then I click go. And this software is called Backyard EOS. It controls a Canon camera, the EOS camera. It also controls Nikon cameras, and it's just a wonderful program for like $50. And the guy is just amazing. And so there you can see Jupiter and a couple of its moons there. All right, and those moons are just as big or bigger than our moon. And what's cool is if you look from night to night, you can see these moons rotate around Jupiter, and they change from night to night, which is just the most amazing thing. If you've never seen it, I highly recommend that. But if you want to see something closer on Jupiter, I'm going to put it on a little bit shorter exposure, because the moons are faint and the planet is bright. So if I go for it, we're going for a 1/16th of a second. Okay, now you can see, you see some cloud bands there. So you can start to see a little bit of some lines across Jupiter there, and it's not a spectacular view, but it's pretty cool. And so that's Jupiter. And what's right next to Jupiter in the night sky is Saturn. And so we're going to be able to click on that and make that go to the next planet on our solar system tour. So we click right here. You probably can't see, but Saturn and Jupiter are getting closer and closer and closer. And so over the next week, and I think it gets the closest on the 12th and 13th and 14th and all the way up to the 19th. So here in Michigan, I highly recommend that you get out there and try to see Jupiter and Saturn, because they're coming so close together, they're almost touching, which is the most amazing thing. I don't think I've ever seen that in my lifetime. Never seen them come that close. And so it's be low, low, low in the southwestern sky, you know, after the sun sets. So in Michigan, we have a lot of clouds this time of year. So if the clouds ever part, then you're going to be able to see this. And so that is Saturn, and it's not the greatest shot. I'm going to try to see if I can try again and get a little bit of a sharper, so you can see those rings. Galileo, yeah, now I can see a little bit better there. Galileo had a pretty crude telescope, as you know, and when he looked at this, he thought it had handles. So it looked like a circle with handles, and so that was the first view of Saturn through a telescope. Yep, and so I want to urge everyone to I'm monitoring. I have an assistant here, and so I'm monitoring the live chat. You can ask any question you want, no problem. And so go ahead and use the live chat. So that was Jupiter and Saturn, and what we're going to do here is I'm going to change the order of the show here, because what we want to try to do is we're going to zoom out to a star, because if we zoom out to a star, then we're able to make sure our focus is perfect, because I want to make sure that our focus is perfect. And there's nothing better to focus on than the star called Vega. Vega is a very bright, very close by star, and it is bluish white, and it is tremendously white, and it's in the western sky. If it was clear tonight, you'd be able to see it. And what's really cool about it, it's only 25 light years away. And if you've seen the movie Contact with Jodie Foster, she was communicating with Vega. So that was kind of cool. So if we just take a 2-second exposure, I'm just taking a 2-second exposure of Vega, and we're going to just check to see how good our focus here. But Vega's 25 light years away, so that's really, I didn't really explain, but the unit of measure for everything we're going to see on this tour of the solar system is, let's say it's light years. We're going to use light years as our unit of measure. Okay, the focus is pretty good there. So, you know, I think that the reason that Saturn and Jupiter weren't so good is because they were so low in the sky. And there's mountains close by, and those mountains sometimes interfere with the quality of our view. So I'm going to try a slightly different, I'm going to make the focus even better. So this is the program that controls the focus, and I have a focuser that is on the telescope, and you just turn it in or out just to make things go a little bit better. What happens here in the desert is that when the sky gets dark at night, now you see what I did, I made the focus works. Okay, so what I have to do is go the other way. 1, 2, 3, 4. As the desert cools down, and you know the desert cools fast, faster than Michigan, because it's drier air and it's higher elevation, things cool down fast out there. And so when things cool down real fast, then it changes the telescope. And you know, it's a very sensitive instrument. Now, you see, that's much better. That's much better. So now we can head to our next tour of the solar system. We're going to go to Mars now. And so Mars is just, let's say, it's about 3 light hours away. So light took 3 hours to get there, to come here from Mars, which is pretty amazing. So we hit go to, and now the telescope's going to move to Mars. And now, I don't know if you folks know, but it was this summer we had the best view of Mars we've had for years. I think I had the best view that I've ever even had through a telescope looking at Mars this summer. It was just spectacular. You can see the telescope moving here, and we are looking at Mars, which is pretty close to overhead here. The telescope shows that it's overheads here. So we're going to now take a 1600th of a second exposure on Mars, and there. So now Mars was close, but it's been getting further away here, and I can zoom in probably a little more here, and you can start to see that it's not a complete circle because only 3/4 of Mars is lit now. It exhibits phases just like the Moon does. So Mars is not as close to us, it's off to the side, and so it's not as spectacular. But boy, when it was close, you could see the white polar cap on the bottom, you could see dark markings, you could see Martians. No, sorry, you couldn't see Martians, that's a joke. But the light from Mars took only about probably half an hour to get here, okay, versus the 25 light years that it took for light to come here from Vega, that star. So it's only a couple hours away. All right. So even though they're not too exciting, let's just look at one more outer planet, Neptune. That's the last one, right? Pluto got demoted. Yeah, I'm not happy about that either. But Pluto got demoted. Yeah, we're not getting any chat. So folks, if you're double check that the chat is working, because I'm not getting any chat here. But here we go. This is going to be Neptune, and Neptune is a dark object because it's so far away. It's a gas giant planet, but it is way out there, billions of miles out, and so we need to lengthen our exposure up to 1/8 of a second.
Yep.
Okay, so the chat is working. Good. So we're going to up this to 1/8 of a second, and we're going to see the little ball called Neptune. And now we skipped Uranus. Remember, we saw Mars, then Jupiter's out from there, and Saturn's out from there, and then Uranus is the next. We're skipping Uranus. We're heading out to Neptune. I'd love to show you a comet, but you know there's no good comets in the sky. And there is a poor little picture of Neptune. So, okay, so we have taken our tour of the solar system, but this telescope is not made for the solar system. This telescope is made for stuff that's further out. And so some of the coolest stuff is like where stars are born. So let's look at a place that is a stellar nursery. And so we go into the chart, and we're going closer to the North Star, which is called Polaris, which, by the way, is not the brightest star. Polaris, the North Star, is not the brightest star. It is just a pretty boring little star. And I'm going to what is called the Bubble Nebula. And I click on that, and we're going to hit go. And you'll see the video, the telescope move in about 8 seconds. We're not going to wait for that. We're just going to carry forward. And oh, we got a question while it's moving. Do we have someone out there in New Mexico to maintain your telescope? That is a great question. Yes, telescopes do require assistance. Stuff happens. Luckily, the stuff that happens can be simply like all you have to do is go and reboot. And in fact, actually, almost everything in life that will work, won't it? You know, just reboot. And so that's usually what I need help for. And yes, our landlord is there on site and ready to help out. And so I had his help just last week working on a camera, and so it worked great. So yes, there's somebody there, and if something goes wrong, they're there. If the roof won't close automatically, they can close it manually. Yeah, there's somebody out there, so that's important. But luckily, I tested everything before I set it up out there. I set up the telescope here in my yard in Saline for 3 months. I played with it, and I made it do everything it's supposed to do, and I pretended like it wasn't just outside my door. And it was by doing that I got comfortable with, okay, everything's going to be operating fine, and we're ready to move it out to the desert. But if I hadn't done that, I think I would have torn my hair out. All right, so let's go full screen on this. This is the Bubble Nebula, and it is a mass of red gas. Oh, here, look, there's a satellite. This is probably one of Elon Musk's Starlink satellites. He's got, what, 1,500 of them up there so far? Hey, we got 2 for 1. Look at this. We've got a star cluster at the bottom right. All right, that's M52, and the Bubble Nebula right here. And so let's go close up on the Bubble Nebula. And the Bubble Nebula is red. It's red gas. It is excited hydrogen gas. And when hydrogen gas is excited, it glows red, just like the glow of a neon bulb, right? Or your fluorescent bulb. It fluoresces. And this is the fundamental building blocks of stars. Hydrogen is the most frequent element in our universe, and it's also where stars are born. And stars are being born in this red gas cloud right now. And I believe, I'm not 100% sure, is that a newly formed star blew this bubble because it turned on. Because as you know, when stars are born, it's the gas gets more and more compressed and more and more compressed and more compressed until finally that nuclear fusion turns on, which is how a star burns and creates light. And that young star blasted out the gas around it and caused a bubble. So this is the Bubble Nebula, and I show it to you because it's where stars are being born. And so our tour is a tour of the universe, and we also want to start as far back in time as we can with the start of a star. And so this is about 1,000 to 2,000 light years away. Okay, so our tour of the solar system was in the manner of hours away. Light only took hours to come here from Neptune. Now we talk about 1,000 years for light. So light left there 1,000 years ago and hit the camera tonight. That's a long journey that those photons just finished up. So that is that's where stars are born. And you saw a new star, which is Vega. Let's move over here and see what happens when stars grow up a little bit, and if they all born in the same cloud, then they can form a star cluster. So this is M52, Messier number 52 in his catalog, and there is about 100 stars in that cluster. So that's kind of fun. But I think next let's look at something where we can see even more stars, because I want to be able to show you even more stars. So what we're going to do here is go to a star cluster called M15, number 15 in the catalog. We go to that, and when stars are being formed, they are born together or alone. And so it's interesting that there's different ways of stars living. A lot of them live alone. I believe that I've read that something like 40% of all stars are double. Certainly a third of all stars are double stars. I didn't know that. Of course, ours isn't. But and we've got a question from Tom. Tom asks, so is it true that since we can now see these stars, they are now burnt out or gone? Great question, Tom. This star cluster is about 5,000 light years away. So we're seeing it as it was 5,000 years ago, because a telescope is a time machine, right? So we are looking back in time 5,000 years. But stars last millions to billions of years. So these young stars are there, and they're going to be there for 1 billion more years. So it's for an object like this that isn't changing much, that it's still there today, just like it was then. And this is an object that doesn't change much. So good question, but no, we're going to it's not changing at all. Now we might look at something, I'll tell you, we might look at something a little later that is changeable. and I'll let you know. Whereas today it's different. But things in our Milky Way aren't changing that much. All right, now we're getting a very nice picture. This is called a globular cluster, and it's a ball of 100,000 stars. So imagine that, a ball of 100,000 stars. There you go. It's called Messier number 15, and these are just most amazing objects because they are so packed in. You look at the center is like burnt out. It's overexposed because there are just so many stars. And I read somewhere that if we orbited one of those stars, we would never have night. It would never be dark because there would be so many nearby stars that we would have hundreds of full moons. So that's a globular cluster, and the interesting thing is that astronomers really aren't sure what caused these and why they're formed, because they are only available outside of our Milky Way. They're kind of like bees buzzing around a hive. They buzz around the top and the bottom of the Milky Way, but they're not in the Milky Way. So why are they there? Many theories are out there for it. I'm not an expert on it, but they kind of are like miniature galaxies. But I like them a lot. They're a lot of fun. This is called M15 Hercules. There's a great one in Hercules. And in order to get a good picture, you got to have a good focus. And as you can see, our focus is good here. You got to have a nice night where it's steady. Seeing is one thing that really affects a telescope. Seeing or scintillation or steadiness of the sky makes a big difference. If the stars are really twinkly, that's kind of nice to see, but it's very bad for taking pictures. Twinkly stars are bad because that means that the atmosphere is all shook up and all moving around, and a jet stream is overhead, and there's a mixture of hot and cold, like the heat from the desert is rising, and it causes all the stars to get very twinkly, and the pictures you're going to take are awful. And the bigger your telescope, the worse you are affected. And my friends in the area here in this telescope ranch who have bigger telescopes, huge telescopes, their nights that are clear that they can't even take a decent picture because it is so bubbly in the atmosphere. It is so shimmery and twinkly that they can't get a decent picture. So that's just something that happens. But luckily my telescope is modestly sized here, and it can take pictures any night, even the nights that are very twinkly. Like tonight. I wanted to say that this globular cluster, in our tour of the universe here, we've gone out to 34,000 light years away. So we are at 34,000 light years away. So we are looking, I think, almost as far as the center of our Milky Way galaxy. So that's pretty far away. 34,000 light years. So what was going on Earth when the light left here? 34,000 years ago, there was humans walking around on Earth, hunter-gatherers, but not much in the way of civilization yet. So that's just an amazing thing to see. That and you know, light travels pretty fast. If I were to turn on a flashlight, it gets across the room in a billionth of a second. But light took 34,000 years to come here from that, and that is a close-by neighbor. So the scale of the universe is amazing. So we've seen a star, we've seen stars where they're born, we saw star clusters. Okay, what happens when a star gets old? Well, just like with humans, stars do die, and we're going to be taking a picture here of a star that is dying, and different stars die in different ways. The stars that are smaller or medium, like our sun is medium, they die in a little bit of a whimper. They will extend, or they'll expend all of their fuel and get all used up and get very tired, and then they start to puff up and they get bigger and bigger, and they puff up, and they just bloat, and they start to lose their atmosphere, and the gas starts to float away and get blown away into a big bubble. And so this big bubble of hot gas is really one of the last steps before a star like our sun is going to die, and it's called a planetary nebula. Because a long time ago people said, that bubble looks like a planet. Well, it's not a planet, it's just a bubble of gas, but their telescopes weren't very good and they didn't know what it was, so that's what they called it. So this is a dying star nebula, and it's about 1,000 light years away, and they call this the Ring Nebula. And you can see why it's called the Ring. It is a ring of gas, and you can see, we'll zoom in. We're zooming in here. You see the star in the center? That's the star that's dying. It's puffed off this hot bubble of gas, and this is hot. This gas is hot. Not as hot as the surface of the star, but still very hot, and it's getting bigger and bigger. So Tom's question earlier said, are things different right now than than what we see them? Okay, we're seeing this as it was 1,000 years ago. What about today? And this is one of those rare objects that is changing, and it would be bigger. If you could see this today, it would be bigger and more spread out. It would still be a circular bubble. Another interesting thing about these dying star nebulas and our sun is it'll puff off this hot gas, it'll get bigger and bigger, and that shell, that bubble, is bigger than the orbit of the Earth. Okay, the orbit of the Earth would fit within this bubble. So what happens to us when that bubble envelops us? Well, quite literally, we're toast. We are burnt. We are burnt up because that gas is hot, very hot, and it will just strip off our atmosphere. No more atmosphere, no more plants, everything burnt. So that's our end. That's the Earth's end, because after that, then it just goes. The star has completely exhausted its fuel, and it falls into just basically puffs out like a candle, just puffs out. There's an interesting thing that to see here is that, see this fuzzy star right there? That's a galaxy. Okay, everything in this picture is in our Milky Way. All the dots is on our Milky Way, and so it's close by, on the order of thousands of light years. That there is another 10,000 times further away than this. Maybe 100,000 times further away. So that's a galaxy. That gives you a little bit of a preview of one of the last things we're going to see is some galaxies, because they're far, far away. So this is a dying star nebula. And so we're going to next one, we're going to go to another. I want to go to another dying star nebula that is a little further along, that is died further long ago. It's also about 1,000 light years away. It's really kind of in that same area of the sky, and it's called the Dumbbell. So I'm clicking on that. We're going to go to that, and so this one is a little bit older, so it's further along in its death, and so you'll see that its shape is different because it had more time for that gas to expand and for it to kill all the inhabitants of any planets around its star. And by the way, astronomers have discovered hundreds and hundreds of other stars that have planets, and some of which might even be the size of the Earth, and some of which might even have an atmosphere. It's kind of an exciting time for astronomers because they are discovering so many of these, and as they get better and better telescopes, they're able to see more and more detail and find more and more of these Earth-like planets, hopefully. And so this is the Dumbbell Nebula, and it's just further along. As you can see, it's a lot further along because there's the star in the center that's dying. There's the bubble, and kind of football shaped, isn't it? And it's a combination of reds and greens here. I forget which is which, but oxygen, Oxygen could be the green. But this bubble has been expanding for a lot longer than that the Ring Nebula did. And so this one has been going for a long time, and as you can see, it's just dispersing. And as Tom asked earlier, you know, is this looking? What's it look like today? Because we're seeing it as it was 1,000 years ago, and today, this bubble would be bigger, more diffuse, and perhaps wouldn't even be visible today, 1,000 years later, because that star is slowly puffing off and giving. So these planetary nebula are some of the coolest things in the sky, and they come in all different colors. I've seen some green ones and some blue ones, but they're all just these bubbles of hot gas that surround the dying star. So that's a cool one to see. And so we go back to the chart. And by the way, I want to tell everybody that if you are interested in this astronomy type stuff, I strongly recommend you get you know, a planetarium program. There's apps for your phone. There's a ton of good apps. I really there's just so many, you can't go wrong, and they're just fun to see. Hey, what's up in the sky? Especially like what's going to be happening over here in the next week or two is, hey, where's Jupiter and Saturn? How close are they together? And because you want to see this, and so I strongly recommend you get an app so that it shows you, hey, what's that bright thing? Well, you use the app. The app tells you what that bright thing is. But what I'm doing right now is I'm zooming into the southwest horizon, and you can see here, look how close Saturn and Jupiter are. I mean, they were almost as close as one in my field of view of my camera, and I will tell you, next week they will be in the same field of view. They will be in the same field of view like with binoculars. So I highly recommend that you get an app, or at least get out there if it's clear some night, and start looking. And this is low in the southwest, right after sunset. Low in the southwest, right after sunset. You got to get out there. Oh, look, little Pluto is right there too. Now, Pluto is very hard to see. It's now they call it a dwarf planet, and so it's been demoted. But it is very faint, very hard to see. And if I took a picture of it, it would be just a faint dot, and you would be very underwhelmed. Oh, we got a question. How long does the exposure need to be to get a really good photo? Yeah, that's a great question. To get a really good photo that I want to print and I want to put on a wall, I need to go 4 hours, 5 hours, 10 hours with my setup. And I've gone as long as 20 hours of exposure. So, yep, you need to have a lot of exposure in order to get. What happens is that you just keep taking pictures, pictures, pictures. I usually take 5-minute exposures, and you just keep on taking 5 minutes, 5 minutes, 5 minutes, 5 minutes, 5 minutes, and then if you use software, it stacks them all up. It adds all those different individual pictures together into one master, and then it'll look really cool. And so that's what I do. So we're talking about hours to take a picture, hours and hours. And so what I'd like to do is I set up the telescope to start taking pictures, and it'll just go all night. So I'll take pictures for 4 or 5 hours straight. And sometimes I'll need 2 nights in order to get a good picture. And but I'm more of the impatient, lazy astronomer here at the ranch, and my compatriots, they take pictures for days. I mean, they in order to get a good picture, a great picture, and their pictures are great, they're taking day-long exposures. Now, if you're doing a 24-hour exposure, you're not going to do it in one night, right? You got to do it over the course of 4 nights, 5 nights. So that's how you get a good picture. Now, the end of a big star's life is not a bubble. When a big star dies, it is a supernova, and that's what this is. It's called a supernova remnant. This star exploded about 6,000 years ago. So about 6,000 years ago, this thing went kapow, I mean, a big time blast, and all of the gas that once was the star just went shooting through space way faster than a bullet. I mean, we're talking about tens of miles per second. And it happened 6,000 years ago, and it's still blowing out through space. This shock wave is still going out through space. And this shock wave is called the Veil Nebula because it looks kind of like a veil. It's semi-transparent, and as I zoom in, you can see all the different folds in the veil. It's got filaments, and these filaments are knots of gases. As the gases are whipping along out in space at high speed, they're just rolling through space. And so this is a supernova. It's called the Veil, and this is an amazing thing to see in a telescope. As well, everything we've seen so far is relatively easy to see in a telescope, and so I highly recommend that you seek one out and see if you can look through a telescope. I'm a member of the Ann Arbor Lowbrows, and we have telescopes on Peach Mountain, which is the university's radio telescope. Because of the COVID, we have not been able to have people out as much as we wanted to. So this summer was a total bust as far as public nights with a telescope. But we're hoping that things will get better in 2021, and we will be able to have people out. So if you just Google the Ann Arbor Lowbrows next spring, next summer, hopefully you'll see that we are having open houses on Peach Mountain, and people will be invited to come on out because it's a great time, because we have many telescopes. We have some telescopes that you need a ladder to look through. You have to get up on a ladder. They're that big, and it really takes a telescope like that to see this. This is not really bright, but it is really cool, and so highly recommend you try to do that. And this is the Veil Nebula, and what we're taking now is another picture of the Veil, and this is the other section, because there are two sections of it. Basically, it's shrapnel, right? It's star shrapnel, and we're going to take another piece of the shrapnel on the other side of the circle in this next picture. And it illustrates something amazing that happens. All right, so this is a zoomed in picture. There we go. So you can see that the shock wave goes from bottom to top, doesn't it? And it's really pointed at the bottom, and it spreads out like a broom at the top. But really cool filamentary structure here, you can see. But one thing I want to show you here is that the shock wave, as it blasts and expands and whips through the universe, it cleans things out like a broom. It cleans space up. It moves dust and dirt away from wherever it is coming. So it is like a cosmic broom. You can see the cosmic broom in this picture. Look at the broom. It's moved the shock wave. The shock wave is moving from left to right. Can you see that there's fewer? I'm sorry. It's moving from right to left, because if you look on the right, there's more stars. If you look on the left, there's less stars. It came from the right, and it's moving to the left, and it's clearing off all of the gunk and the dust that's interstellar. So the stuff on the left still has junk that we can't see, but on the right it's nice and clear. It's kind of like after a storm goes through, the sky is nice and clear. Same thing. Sky is real clear on the right, and we got dust on the left. So the shock wave is just moving to the left, and it's clearing things out. So I love to show this to people. It really shows that these shock waves really are a broom out there in space. And Tom has a question about the Kuiper Belt. The Kuiper Belt is definitely a region that we have for our in our solar system, and I believe the Kuiper Belt is a little bit further out, and we have beyond Pluto. There's even more stuff, and the Kuiper Belt is out there, and objects can be captured with gravity, and they kind of pull into the orbit with the Earth, and that's the way. And the Oort cloud is further out, and that's where comets can come from. We also have a question about, and while we're waiting for the telescope to come back, because things are really slow out there, we have a question about can we see the Andromeda Galaxy? And the answer is yes. And the Andromeda Galaxy is going to be our next object. So as soon as we are rehooked up here, we're going to look at the Andromeda Galaxy because that is our closest neighbor. But while we're waiting for this, there's another question that we've got is, where is the closest dark area near Ann Arbor to take a picture of the night sky? And that's a great question. Where is the closest dark sky area near Ann Arbor to take a picture of the night sky? And it's a great question because you can't get a decent picture of the night sky from Ann Arbor. We have just too much light pollution. It is just not good. So you got to get away from light pollution. Well, where do you go? Well, you want to get out in the country. You want to get out away from city lights where you can really see the Milky Way. Because if you can see the Milky Way, you can get a pretty good picture. So I always recommend people to go to some of the dark sky parks. There's dark sky preserves, places where they really set them aside where you can't have a lot of lights. And so that's where the best place is to go. And the closest one is Lake Hudson. So you can Google Lake Hudson. And Lake Hudson is about an hour from Ann Arbor. And it's down by Adrian. And I highly recommend, highly recommend you get down there to Lake Hudson. And on a summer Friday or Saturday night, you're going to see lots of astronomers, not lots, but you're going to see a handful of astronomers and astrophotographers down there taking pictures. And it's a great spot. It's less than an hour away. I highly recommend you get down there and do that because it's tons of fun. But in order to do this, you need to have some instructions. And I know that a library employee, Amy Cantu, has produced a wonderful video that shows you how to do this. And it may not be up online, but it will be very shortly at AADL. And I would highly recommend that you take a look at Amy's video that shows you how to do this. She shows you what equipment to get together, the camera, the tripod, which type of lens, and how you put it all together. Totally critical to get out there because nowadays everybody wants to take a picture of the Milky Way, and you can do it, and it's not hard. And I'll give you more details, but this is the most impressive thing that I can show you. So this is the Andromeda Galaxy. This is the WOW object. This is our closest neighbor. And if they were looking at us, we would look pretty similar to this because we're both spiral galaxies. Our Milky Way looks like this. This is our closest neighbor. And the light left there 2.5 million years ago. So imagine that. This galaxy is so far away that it took 2.5 million years for that light to get here. And its journey ended inside my camera. It is incomprehensible. The size of the universe is incomprehensible, and it's one reason why I say it's huge. There's other stars, and there's very likely other planets, and it could very well be there's life on those planets as well. But the distance is so immense that we may not know that they're there, and they don't know that we're here because we're so far apart we can't communicate. Now this is the Andromeda Galaxy, our closest neighbor. In the center is the bright nucleus, and there's probably a black hole in there, just like there's a black hole within our and most galaxies. So that's why it's so bright, but it's just packed really together with stars. You can see the spiral arms, and this dark stuff is clouds of dust, dark dust. And so this dark dust prevents us from seeing the glow of the stars behind it. And you can see many of these dark dust lanes that move around here. In addition, it's got two siblings. It's got two other galaxies that it has grabbed in its tractor beam and grabbed and kept in. So we have Messier 32 right here and number 110 right here. And so it has two companion galaxies, and we have a couple also, the Magellanic Clouds, which you can see if you go to South America. The Magellanic Clouds are nearby galaxies that are in the southern sky. We can't see them here. I'd like to see them myself someday. I haven't been able to do that. But one thing I just noticed is that my I still have the camera on. I have the night vision camera on my telescope, so it's not good because my camera is sensitive to these infrared, and I got an infrared light on there. Well, it's not really ruining our picture too much. But one thing I would like to show you is this is kind of a clue as to what you might do to make a picture a better picture. Because when you get the picture straight out of the camera, it's good, it's cool, but there's usually a lot of work to do after the fact. After you've got the picture, let's say like we discussed before, you need to have several images and you stack them up, right? You have like 10 or 20 images, you stack them together, and there's Photoshop is a tool we use, but this program has a little bit of image processing, and so I'm going to just pull on one of the adjusters on this picture just to show you here. Yeah, we got some things that are darker, some things that are lighter. And so what we've done here is we've just increased the contrast, okay? And maybe I didn't make it better, but it just shows you that there are a lot of different things you can do, usually with Photoshop, to bring out detail. And what I would just want to show you right there is that I did something to make those dust lanes more evident. So that's one great thing about this picture is you can see that you can see some of these small little knots of red gas and blue gas where stars are being born. There's spots here where stars are being born right there, so it's really kind of cool to see that. All right, so we have seen that, and so there's one more galaxy I want to show you before our time's up, and then maybe one more far away thing to see after that. So this is the Andromeda Galaxy, and a little further away but smaller is the Pinwheel Galaxy, and the Pinwheel is at a different angle. As you can see, the Andromeda Galaxy is kind of at an angle to us, right? It's kind of at a 45-degree angle to us, right? This one is straight on. So it's called face on, and so this one you can really see the spiral structure better than really any other galaxy in the sky. So this is the Pinwheel, and one thing cool about these objects is that you can see them. You know, if you got binoculars, if you can get out of Ann Arbor, get away from city lights, like I said, Lake Hudson, other places you can go. Up to the thumb, Port Crescent State Park. Port Crescent is a dark sky park as well. Their day use area, where they have the hawk viewing and the bird viewing by the beach, is a great place, nice and dark there. Anywhere in the UP, Sleeping Bear Dunes, up by up by Mackinac City, the Headlands, and they have a great observatory up there in places that you can they'll have tours of the sky at Headlands, which is way up at the top of lower Michigan. So that's just a few that you can choose from. So let's take a look here at the Pinwhale Galaxy, and now very nice. It's got a really nice view of the spiral arms. How many spiral arms can we count? Well, there's one. If you start at the beginning, start at the center, there's one that curves out this way. That's one. And then there's another one that curves out this way, two. Maybe a third going this way, and a fourth going that way. Anyhow, that is this is the Pinwheel Galaxy, and what is really amazing about the Pinwheel is that it's birthing stars at a tremendous rate. This is a very, very fertile galaxy. It has having an explosion of stars. And you know this because of these red clots of gas, just like that bubble, right? Well, this right here is like the bubble times 10,000. There are thousands of stars being born right now, right in that clot, that red clot, and this one over here, another one, and every red bit you can see on the screen is where stars are being born. So this is called the Pinwheel, and this one, like Andromeda, is visible to the naked eye if you get out way, way, way out where it's dark, and you let your eyes get used to the dark. Another thing I have to tell you is that it's important to let your eyes get used to the dark. Okay, if you drive somewhere out in the country, right, and you want to see the stars, you can't just drive there, get out of your car, and expect to see stuff like this, because it takes half hour, 45 minutes for your eyes to adjust to the dark. And I was recently out at Lake Hudson, and some people had come for the meteor shower, and they sat in their car with the lights on for an hour, hoping to see meteors. It was cold, so they stayed in the car, but I bet you they saw nothing. Nothing at all. So you got to get out, you got to dress warm, and get out there ready to see the stars. But let your eyes get used to it, and don't look at your phone. Okay, the phone is the enemy of dark adapted eyes, because the phone is bright, right? And so you're just ruining your eyesight by looking at your phone. Our final object is the furthest thing that this telescope is going to be able to see. And this is a quasar. What's a quasar? Well, quasar is a QSO, quasi-stellar object. When astronomers first saw these things, I believe we're seeing tremendous radio emissions. The radio telescopes and X-ray telescopes were giving huge amounts of signal. Yet the optical telescopes, like this, just shows just a dot. And so they wondered, what is that thing? And they measured the redshift, or the distance away, and this thing is 1 billion light years away. Billion with a B. So this is again another 1,000 times further than Andromeda, and took a long time, but they figured out that these are super bright galaxies where the nucleus is so bright that it's caused by they're actively feeding huge black holes. So there's a black hole in the center, and this is it right here. I'm going to zoom way in. It's just a dot, but this dot is a galaxy that is 1 billion light years away. Okay, light left there before there was much life on Earth. So I'll say it again. These quasars are super bright galaxies that are caused by the active feeding of black holes. When these huge black holes are munching up all the stars and matter, the matter that they can put out these jets of super bright beams, and that's what this is. It's basically a beam coming at us from 1 billion light years away. So that is the last thing we're going to see, because that's the furthest thing that I have ever seen, and that's the furthest thing you're going to ever see, unless you do something like a gravitational lens, but that's a topic for a different night. So we're after 9 o'clock. We're going to have to say goodbye, and I wish to have you some other time, and we'll just look at some other items and try to do a whole different show. Perhaps we'll even chase the space station. So, okay, there's a question here. Dr. Darelevel asked a good question about Andromeda. Yes, we are on a collision course with Andromeda. Luckily, it's going to be not for a couple billion years. But yes, we are heading towards them, and they're heading towards us. But the thing is, it's like a swarm of bees hitting another swarm of bees. They're going to go through each other. There's not going to be a lot of contact, not a lot of violence. Although, sometimes, if we get close, the gravity will hurt us. So that's a good question. So, yeah, we're going to have a collision with Andromeda, but don't worry, we got a couple billion years, so it's not going to happen. But one thing I do want to show you next time is we'll chase the space station. I know there's more humans up there right now than normal, right? There's like 4 people up there, 5, and but it's not available tonight, or else I would have showed you. So next time we'll chase the space station and try to get a close-up picture of that. So I urge you to watch Amy's video on astrophotography, and I'm going to finish up with a little slideshow. I have Instagram, and you can see my pictures on Instagram. My handle on Instagram is AstroPixDaily. AstroPixDaily. So good night, and we'll see you next time.